Multiplying with Fractions, Part 3 by Jeff Simpson. This video deals with problems like this. That's multiplying proper fractions with mixed numbers and improper fractions. Pictures of food and money are helpful in understanding fractions, so here are some pictures to help you learn about multiplying proper fractions times mixed numbers and improper fractions. Imagine 2 whole pans of brownies. Now imagine that both are cut into halves, and that half of one of the pans is gone, and that you get to keep 1½ pans of brownies. 1½ Then you decide to give half of your 1½ pans of brownies to a friend. So you take what you have, you cut it into halves, and get it ready to give away to your friend. Well, before you had 1½. But then you gave half of it away. So how much do you have now? What fraction is it? If you draw some lines and rearrange, you can see that you have 3/4 of a pan of brownies. Half of 1½ is the same as 3/4. Half of 1½ Of, notice that word. As you learned in the Part 2 video, of means to multiply. Half of 1½ means half times 1½, or with all numbers, 1/2 times 1½ Someone invented a clever way of dealing with this. They noticed that 1½ is the same as 3/2. I'll show you what I mean. Here's 1/2, 2/2, 3/2. Same as 1½ They also noticed that if you multiply 2 times 1, that's the denominator down there, 2, times the whole number, 2 times 1, and then add 1 to that, that's adding the numerator, 2 times 1 plus 1 is 3. 3/2. You can change the mixed number, 1½ into an improper fraction, 3/2. 2 different names for the same thing. 1½ equals 3/2. We know from the picture that this is true. 1½ is a mixed number. The same thing split up in a different way is 3/2, which is an improper fraction. As you learned in the Part 2 video, you multiply the top numbers, that's the numerator times the numerator, so 1 times 3 is 3. Then you multiply the bottom numbers, that's the denominator times the denominator, 2 times 2, which is 4. And we know from the picture that this is true. Here's 1½ which is the same as 3/2. Now let's take half of that. Draw lines, rearrange, and we can see 1/2 of 3/2 is 3/4. 3/2 is a little strange for a fraction, don't you think? It's not what you'd expect a fraction to be. People usually think of a fraction as a part of something. Proper is a good word to use here. Proper means correct or appropriate, or the way something is supposed to be, like proper behavior. 1/2 is an example of a proper fraction because it's a part of something like you'd expect a fraction to be. Improper, on the other hand, means not correct, not appropriate, not the way something's supposed to be, like improper behavior. 3/2, for example, is an improper fraction because it's not a part of something like you'd expect a fraction to be. It's more than one whole thing. Here's a similar problem that we can work the same way. 2/3 of 5/4, or in other words, 2/3 times 5/4. Well, first you multiply the numerators. 2 times 5 is 10. Then you multiply the denominators. 3 times 4 is 12. Let's have a look at the picture of this. 1/4, 2/4, 3/4, 5/4. Now we're going to take 2/3 of that. We'll cut all these into thirds. Now look at the first fourth. We only have 2/3 of that fourth now. Let's do the same thing with the next fourth. 2/3 of that fourth. And we'll do it again. 2/3 of a fourth, and again 2/3 of a fourth. There, we've done it 5 times. 3, 4, 5. So this is a picture of 2/3 of 5/4. Let's do some rearranging here. And we can see we've got a lot of twelfths. There's 10 of them, 10 twelfths. The picture proves that 2/3 of 5/4 is 10 twelfths. Can the product 10 twelfths be reduced? Yes. Divide the numerator by 2. So 10 divided by 2 is 5. Then divide the denominator by 2. 12 divided by 2 is 6. Remove some lines, and there you have it, 5/6. The picture shows that 10 twelfths is the same thing as 5/6. They're equal. 2/3 of 5/4. When you reduce the end product, it's 5/6. Did you notice that 5/4, an improper fraction, is equal to 1 and 1/4, which is a mixed number? So 2/3 of 5/4 is actually the same as 2/3 of 1 and 1/4. When multiplying 2 times 5 or 5 times 2, either way you do it, you're going to get 10. That's the commutative property at work. So is 2 times 5 the same as 5 times 2? Well, the result is the same, but the picture is not the same. I'll show you what I mean. Let's say take 2 of these $5 bills. 2 5s is 2 times 5, which is $10. But take 5 of these, that's $2 bills. So you got 5 2s, 5 times 2 is also 10. Now the same is true when we multiply fractions. When we switch the numbers around, the result is the same. So if you have 1/2 times 3/2, you can switch the order of the numbers and lead off with 3/2 times 1/2. And either way, you're going to get 3/4 for the product. The products are the same, but the pictures are different. Let's take a look at the pictures. We already know that the picture of 1/2 of 3/2 looks like this. There's 3/2, and we take half of that, draw lines, rearrange, and we can see that equals 3/4. But what does a picture of 3/2 of 1/2 look like? Well, let's start with 1/2. Now, let's move half of a half over to another pan. So first we have to cut that half in half. Bring another pan ready. There's half of a half. and we'll move it over there. Half of a half. Let's do it again. Move another half of a half. And now let's again move one more half of a half. We've done it 3 times. Here on the left, this is 1/2. Over on the right, this is 3 halves of a half, which is 3/4. 3 halves of 1/2 is 3/4. Now that you understand how to work these problems, you should know that there is a shortcut way of doing them called cross-canceling. I made a video on that. You can click on the icon and watch my video on cross-canceling. You might also be interested in watching my videos on dividing with fractions. That is all for the Part 3 video. Thanks for watching. Please share these ideas with other people who can benefit from them.